Hi there! I'm about to schedule the irrigation for this field, which means I need to work out how frequently I need to irrigate. This field's soil type is silt loam, and the ETC is known. We highly recommend watching the previous videos in this series to understand those parameters. So, we already know how much to irrigate, but when should we set the next irrigation event? That's what we're about to learn in this video. Our goal is to maintain the soil water content within the readily available water. How do we do this? We irrigate to bring soil water content a little above field capacity. The soil water content decreases due to drainage, plant consumption, and evaporation. When it reaches the depletion threshold, we irrigate again. Simple and precise. So we need to find the time interval between point A and point B. Those points represent the lowest level of water content and are the trigger for another irrigation event. Remember, for each soil type, the depletion threshold and the soil water dynamics are different. Finding the time interval can be done by digging and evaluating soil moisture, or by using sensors, or by using a calculation that we're about to learn. Just before that, as you know, with precision irrigation, you're not irrigating the full soil profile. We're targeting the main root zone, where 85% of the roots are distributed. We call this the effective root zone. In this method, we create wetted and dry areas, and when irrigating, we need to make sure the wetted areas covers the effective root zone and calculate the interval accordingly. To calculate the interval value, we use the following equation: RAW divided by the ETC. Let's start by finding the values, with RAW first. The RAW is a calculated value. Multiplying the TAW by the depletion threshold will give us the RAW value. Now let's focus on total available water. TAW is the result of field capacity minus wilting point. Those values are available in the FAO soil table on the internet. Alternatively, for your convenience, you can use the link in this video's description below. This field soil type is silt loam, and according to the FAO soil table, the value of field capacity is 33%, and the value of the wilting point is 13%. 33 minus 13 equals 20. And as shown in the table, 20% is equal to 200 millimeters, giving us a 200 millimeters of TAW in 1 meter of soil profile. Now we narrow this number to the effective root zone, also defined as the wetted area. To do this, we need to calculate the percentage of wetted area in the field. 100% of the field divided by the distance between the dripper lines, multiplied by the wetted area's width and depth. The width and depth of the wetted area change according to each specific crop and condition. So ask your agronomy advisor for the appropriate values. Otherwise, you can use the following constant numbers: 30 centimeters width and 50 centimeters depth. Those numbers are generic and will help you make a general calculation. Consult an agronomy advisor for specific values to achieve precise results. We'll use the constant numbers for our example. The distance between dripper lines in this field is 1.5 meters. So 100 divided by 1.5 multiplied by 0.3 multiplied by 0.5 equals 10. That means 10% of the field is wetted. Finally, to quantify the volume of TAW in the wetted area, multiply the TAW value of the whole soil profile by the wetted area. 10% of 200 millimeters equals 20 millimeters, giving you the TAW in the wetted area. Now to the depletion threshold. A short reminder: the depletion threshold is within the TAW and indicates the lowest content of available water in the soil that we've set. In our example, the depletion threshold is set to 50%. After finding the required values, we can calculate the RAW. 50% of 20 millimeters is 10 millimeters, and that is the RAW value of this field. Back to the interval equation, we substitute the RAW value. Now let's find the ETC. As you know, the ETC value changes daily, so you need to choose either the max ETC of the season, or to be more precise, the max ETC of the crop's current development stage. The cotton in this field is at a vegetative development stage, and the max ETC of this stage is 5 millimeters. We'll use this value for the calculation. Now let's do the math. 10 divided by 5 equals 2. This gives us the time interval between irrigation events. This means we need to irrigate our field with 10 millimeters of water every 2 days. Now that we know the irrigation interval, we can be even more precise. Instead of max ETC, add up the ETC of the last 2 days and irrigate the exact amount in the same calculated interval. Now a question. What if we had different values in the equation and the interval was 3.3? Since we cannot irrigate in fractions of days, we round off the result. In this case, we round down to 3 days. Now the irrigation is adapted to the soil type. It's more precise and beneficial for the plants. Irrigation scheduling is affected by other parameters as well, such as plant traits, salinity, operational constraints, soil permeability, and others. Each one of these parameters can be calculated as well. The scheduling is also affected by agronomical decisions, such as applied stress or profile filling. But the leading parameter will be the water holding capacity of the soil, and the calculations described above will give you a good understanding of your optimal irrigation scheduling. Have a successful irrigation season!